So this one is already factored for you. Sometimes you have to factor it. This one you don't have to. The first thing to do is find the zeros, because if we want to know where does this, where is that less than 0? So really it's where is it negative. So what numbers make that negative? Instead of just having to pick every number that there is, we can figure out what makes it 0, and then we can figure out what sections, each section of numbers from those zeros are going to make it either positive or negative. So we know that x equals 5 over 2, negative 3, and negative 5. So then we make our sign chart. So a sign chart is just a line graph. Make sure these are in order. Negative 5, negative 3, and 5 over 2. So we have these 4 sections of the graph. Now this says less than 0, so it can't be 0. Less than or equal to 0, 0 would be okay. So we need these open dots right here. If that was less than or equal to, they'd be closed dots. And the dots are important because sometimes there's a dot that's part of the answer and it's not part of the shaded answer, so you have to include it. Or sometimes you go from, like, if negative 5 to 5 over 2 is the answer and we went through negative 3, we would not be able to include negative 3. So it's important to put those open or closed dots on your graph. Not that we're going to be grading the open or closed dots, but it's going to show up in your answer. And if you don't put them on your graph, then it could affect your answer if you don't know what you're doing. All right. So a couple different ways to do this. One way is to just put a bunch of parentheses. So we have a factor, and a factor. So we put 3 parentheses in each section. 3 in each section. And all we care about are the signs. We don't care about the value. When I plug in a number in that section, is the value going to be positive or is it going to be negative? Now, this one is kind of nice. Anytime we see something squared, no matter what we get in the parentheses, we're going to square it and it's going to be positive. So we could go ahead and go through each and put a plus in each of the first ones, because that's going to happen no matter what. All right, then we have to worry about these other 2 parentheses. So if I pick a number somewhere less than negative 5, negative 7. If I pick negative 7 and plug it in right there, I'm going to get a negative. Negative 7 plus 5 is a negative. So that section turns out being positive. And I move on to the next section. I'm going to pick negative 4. Negative 4 plus 3 is negative. Negative 4 plus 5 is positive. That section ends up being negative. Now, don't just assume plus, minus. In Algebra 2, that might have happened. Doesn't necessarily happen anymore. It might, but it might not. So we can't just assume. Then I pick 0. 0 plus 3 is positive. 0 plus 5 is positive, so that section's positive. And then if I pick 8, 8 plus 3 is positive. 8 plus 5 is positive, so that section's positive. So now I'm looking for where is that. There's the graph. Here's where this function is positive, this function's negative, this function's positive and positive. So this is the part that we care about. So our answer is negative 5 to negative 3, and they are parentheses. If there was an equal sign in that problem, all that would change is those would be brackets. That's how that problem would change. Now, another way that you could do this is you can just use negative signs. Okay, so I'm going to do this one a little bit different now. So if we did the same thing, really all we care about is negatives. Because if we have positives, 2 positives, 3 positives, 4 positives, doesn't matter. If they're all positive, they're positive. But 1 negative makes it negative. 2 negatives make it positive. 3 negatives make it negative. 4 negatives, and so forth. So really all that matters is the negative signs. Well, is this factor ever going to be negative? No. So we don't even have to worry about that. So that doesn't even matter. Those are always positive. But these other 2, negative 5, the only thing that makes that negative is anything less than negative 5. The only thing that makes x plus 3 negative is anything less than negative 3. So those negative signs are really all that matter. Negative times negative is positive. We already got that. a negative by itself is a negative. If it doesn't have any sign, no negatives mean it's positive, and we get the answer the same way. Now, maybe your Algebra 2 teacher showed you that, and that makes sense. If that green that I just wrote doesn't make any sense, and you were like, what did you just do? Okay, then just do the parentheses. The parentheses are fine. But if sign analysis is easy to you, you remember it, your teacher taught you that, then you can just worry about the negative signs. But if that doesn't make sense, then just use the parentheses. I'll do another one in a second with the negatives to see if you want to learn that way, because it's a little bit shorter, but there are some exceptions. Whenever we do a little shortcut, there's always exceptions to that. So I'll talk about that in a second when we get to that. All right, so here, already factored, x equals negative 1/2, x equals 3. So in order, negative 1/2 and 3. I would not suggest putting 0 in the middle and plotting those points, because now is 0 a root or not? You don't know. So just put the numbers on your sign chart that matter. And greater than or equal to, so that means they are closed dots. And we have two factors, factor, factor. Now this one we don't really necessarily want to use that shortcut because this x is negative. That shortcut really only works when the x is positive, or you just have to remember everything's backwards, the opposite of what x would actually be. So again, the shortcut you really only want to use when you kind of have normal factors. So that's what I do. When I have just normal factors, I would use that. I would not use the shortcut on this problem because the x is negative. All right, so if I plug in negative 6, I get a negative, negative 6. 3 minus negative 6 is a positive, so that section's negative. If I plug in 0, I get a positive, 0, I get a positive, so that section is positive. And I just circle mine so I can see what I'm looking at. You don't have to circle it. You don't even have to put this. I want either the two factor signs or the one sign. One or the other is fine. Both is fine. But at least one of them. I need to see what your signs are in your sign chart. That's the work to justify your answer. And then if I plug in 6, I get plus. 3 minus 6 is minus. So that section is negative. And I want greater than or equal to 0. So that's that middle section. Bracket, negative 1/2 to 3 bracket. Those are the values that make that polynomial, if we were to multiply it out, positive. All right, so this one we do have to factor. First, we have to take out a GCF of x. 3x squared plus 7x minus 6. We can't divide by x, okay? Never, ever divide by x. Just like in the trig unit, you don't divide by words, you don't divide by letters, you can only divide by numbers. You start dividing by words and letters, solutions go away. You cannot divide and get rid of words or letters. They're part of the problem. So we keep that x there. 3x and x. Remember, when you're guessing and checking, there was no GCF. 3, 7, and 6 had nothing in common. No GCF. Therefore, our factors down here can't have GCF. So the 6 cannot go here. The 3 cannot go here. So our only options are 1 and 6 or 2 and 3. So 2 and 3 give us a 9 and a 2. So plus 9 minus 2 works. And then our zeros are x equals 0, 2/3, and negative 3. And you don't have to write those down. You can just put them straight on your sign chart if you want. Be sure they're in order. Negative 3, 0, and 2/3. And they are all closed dots. And if we want to do our signs, so let me do this one with the signs. So I'm going to go to just, all I care about are the negative signs. So let's just think about it. Let's think about if I plug in this factor right here, x plus 3. If I plug in a number, if I'm only looking at x plus 3, any number I plug in to the left of negative 3. Negative 4, negative 5, negative 6 is going to be negative. Anything to the right, negative 2 is positive. Negative 1 is positive. 0 is positive. 1. So anything to the right of that is positive. Think about 0. At 0, anything to the left of 0 is negative. Anything to the right is positive. 2/3. Anything to the left, if I plug in 0, I get a negative. If I plug in negative 1, I get a negative. If I plug in a 1, I get a positive. So that's why we can use that little shortcut. So 2/3, negative, negative, negative. 0, negative, negative. Negative 3, negative. Only things to the left are negative, to the right is positive. And that works because we have 3 normal factors here, an x, a 3x, and an x. All the x's were first, nothing was squared. So 3 negatives make a negative, 2 negatives make a positive, 1 negative makes a negative, no negatives make a positive. Everything's positive until you start putting negatives in. Now, if you don't like that method and you want to use your parentheses, that is quite all right. Each section has 3 sets of parentheses. If I plug in a negative 5 gives me negative, negative 5, negative, negative 5, negative. I still get a negative. I plug in a negative 2, negative 2, negative, negative, negative 2, positive. When I multiply those, I get a positive. 1/3, I guess. 1/3 would be positive. 1/3 negative. 1/3 positive. 10 positive. 30 minus 2 positive. 10 plus 3 positive. You pick which way you like best. Okay? Either way is fine. Just know that if you just use your negatives, it's a little bit of a shortcut, and it works when they're nice normal factors. When we start doing squares and flipping them, having the x be negative, that changes. All right, so we want less than 0, so that's this section and this section. So that would be negative infinity to negative 3, bracket, in union with 0 to 2/3. And there is your answer. All of those numbers in that section would make that polynomial either less than or equal to 0. So either negative or 0. But it's okay to be 0. That's why we have brackets. All right, so first we got to bring everything over because we need this to be less than 0. We need that 0 on the right. Put the 0 on the other side, everything's just backwards. So I like negatives to be to the left and positives to be the right. So therefore we need our 0 on the far right. Now, because we are solving, we can get rid of negative 2. We can't just get rid of negative 2 if there's no inequality or equal sign. But if there's some kind of equality symbol, inequality symbol, we can do that. I see that everything is even. I don't like that negative, so I'm going to divide this side by negative 2, so I can divide this side by negative 2. I can only do that when there's an equation or inequality. If that's not the case, I can't just say, well, I don't like the number 10, I like the number 5 better, so I'm just going to divide it by 2. Okay? Just because you can doesn't mean you can just change it. That changes the problem. 10x equals 5, you can divide both sides by 10, but not just because. All right, so that gives us x to the 4th minus 5x squared plus 6. Because I divided by a negative, flips the symbol greater than 0. We could have just factored it out. If we just factored out a -2, that would just be one of our factors that affected our plus and minus signs. But now we don't have to worry about that. We got rid of it, so it flipped the symbol. So now we have to factor this. X to the 4th is x squared. Now, 6 and 1 can get us a 5. 2 and 3 can get us a 5. There are never two answers, ever. Never, ever are there two answers to factoring a polynomial, okay, or two different sets of two answers. Our only possibility, because this is plus, that tells us the signs are the same. Because this is minus, that tells us they're both minus. Therefore, we have to use 2 and 3. -6 plus 1 is -5. But -6 times +1 is not +6. So that's why we cannot use -6 plus 1. Now, from this point, a couple different things you can do. This is not a different, 2 is not a perfect square, but we could kind of make it a perfect square. The square root of 2 times the square root of 2. What two numbers multiply together to give us 2? Root 2 times root 2. So you could factor that. I wouldn't expect you to factor that, but some of you could see that, so I just wanted to put that out there. You could do x plus root 2, x minus root 2. That's a possibility if you can see that. Or when we get to this point, we can say x squared minus 2 equals 0, x squared minus 3 equals 0, x squared equals 2. So x equals plus or minus root 2. If you solve using square roots, you've got to remember the plus and minuses. If you don't remember the plus and minuses, you might want to think about factoring. Same thing here. X squared equals 3, so x equals plus or minus root 3. Or x plus root 3 times x minus root 3. Either one will work. Doesn't matter which way you do it, because it does not say factor completely. You could, I guess, use the quadratic formula. I would not suggest that, okay, when you don't have an x term, but it is possible. All right, so we have these 4 roots. Plus and minus is root 2. This is where that minus method is kind of nice, because we don't necessarily know what these values are. We should know that root 3 is bigger than root 2, therefore negative root 3 is smaller. So negative root 3, negative root 2, root 2, root 3. So if we use our minus method, or let's think, I think these were all open. Yes, just what did we change it to? Greater than. All right, so picking a number smaller than negative root 3 is easy. But what about picking a number between root 3 and root 2? Not as easy. So this is when, if we use our minuses, it's very helpful. It's going to be much, much easier. Start from the left or the right, it doesn't matter. If I start from the right, I'm going to make each section negative for this factor, or root. Then I go here. I'm going to make negatives all the way to the left. Here, negative, negative. Here, negative. The reason we're not writing positives is because positives don't affect anything. Doesn't matter if you put a positive. Doesn't matter how many positives are there. That's not going to change anything. So 4 negatives make a positive. 3 make a negative. 2 make a positive. 1 makes a negative. None make a positive. And it's just a lot easier than trying to pick numbers that are in between negative root 2 and root 3 that you might not know. If not, you've got to know that root 2 is about 1.4, root 3 is about 1.7, so 1.5, 1.6, any of those will work. You just got to plug them in and figure it out then. But if you use this method, because all of our factors are normal, we can do that. So we want to know, where is it greater than 0? So that's where the section's where it's positive. So negative infinity to negative root 3, union, negative root 2 to root 2, union, root 3 to infinity. So there is your answer in interval notation. These will always ask for your answer in interval notation. It'll say use sign analysis. Sign analysis is that sign chart right there with either plus or minus signs. So it's some kind of plus and minus signs, some indication of what that section is. Whether you actually show me what it is, those 4 negative signs is fine. I know that you know 4 negative signs is positive, and then it'll show up in your answer if you do know that. I just like putting them there because then it's easy to pull the intervals into my answer. All right, and then these last two, not necessarily polynomials, but it goes along with sign analysis. So these are rationals. We do have a unit later on that is rationals, but we're just talking about sign analysis here, so kind of got put in there. We have a denominator. As far as finding our zeros is nothing different. -2, 5, and 4. So that all stays the same. -2, 4, and 5. What's a little different is our circles. Now if we took, let's ignore this 4 for a minute. So if we have that numerator less than or equal to 0, that means it's okay to be 0. It's okay to be 0. But now we have a denominator. It is not okay for the denominator to be 0. Therefore, at 4, there's an open dot. So denominators cannot equal 0, so always an open dot. It is not ever included, which means not included. Everything all the way up to 4, 3.999, 4.001 is okay, but 4 is not. The denominator can never equal 0. That makes it undefined. I'll do our parenthesis method here. So parenthesis top. Now, multiplying or dividing positive and negatives, there's no difference, right? Whether you're dividing 2 negatives or multiplying 2 negatives, it's still positive. And this one also has a squared, so we could go ahead and put a plus in all of those top right factors because it's squared. Doesn't matter what happens in the parentheses. You're going to square it, and it's going to become positive. So now we do everything the same. If I plug, so if I want to pick a point, now if you like your negative method and that makes sense what I've been doing, fine. I'm just doing it different ways so you can see which one you like best. -3 would be negative. -3 would be negative. So that section, positive. 0, positive, negative. So that section's negative. 4.5. Positive, positive, so that section's positive. And 6. 8 is positive, 6 minus 4 is positive, so that section's positive. And we want where it is less than or equal to 0. So less than or equal to 0. Can't forget about that dot right there that's all by itself. It's okay to be equal to 0. So we have that little section and that dot. So the way we would write our answer is bracket -2, 4, parenthesis, in union with the way you show just one single point is that number in brackets all by itself. So if you have a random number that's a dot, that's why those dots are important, because if you don't put those dots, you wouldn't include that 5. That 5 would not be included. So everything around 5 makes that particular function positive, but 5 makes it equal to 0, so that's why we have to include it. And then our last one just requires us to do a little bit of factoring. So n and n, 2 and 2, both signs are plus. Here, GCF of n. So factor that n out. Now, our numerator, we have n plus 2, n plus 2, so we can rewrite that as n plus 2 squared, if we want, over n times n plus 4 greater than 0. Now, this one doesn't have an equal sign, so it doesn't matter about that denominator. Everything's going to be an open dot. -4 is open, -2 is open, and 0. All of them are open. So again, if you like your parenthesis method, I'll do that again. And maybe you don't need to put all those parentheses. I just do because I'm going to fill them in. And that numerator, now let's say you didn't recognize that that was n plus 2 squared, and you had n plus 2 times n plus 2. Well, if you have the same thing, and you're plugging in the same number into the same thing, you're going to get the same positive or negative, the same positive. You're going to both get positive or both get negative, and still end up with the same sign in the numerator. All right, this n all by itself. So if I plug in a negative, it's going to be negative. If I plug in a negative, negative. If I plug in a negative, negative. If I plug in a positive, it's positive. And then the n plus 4. This matters what number. The n nothing was being added or subtracted to it, but it's n plus 4. So -5 plus 4 is negative. So that section ends up being positive. -3 plus 4 is positive. So we got negative. -1 plus 4 is positive, so we've got a negative. And 10 plus 4 is positive, so we have a positive. And we want greater than 0, so there's that section right there. -infinity to -4, parenthesis, union, 0 to infinity. Now, kind of a little side note on this one. If, okay? So if this had been less than, we would have wanted this section and this section, but notice that -2 is not part of it. So if it had been less than, we would have to be sure and not include that -2. We wouldn't just say -4 to 0 because that's not true. We go from -4, that's why that dot is important, because if that dot wasn't there, you might just squiggle your line all the way through that. We know that it can't be -2 because there's no equal sign. So that's why that open dot was there. So again, if we'd flipped that, it would have been the inside section, but excluding that -2, and this is how you exclude a number. You just write the number. You write the number again. That means everything from -4 up to -2, but not including the -2. So that is how you exclude